Welcome to Smart Software with Smart Logic, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justice Eben, and I'm your host today, a developer here at Smart Logic. We are a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. I am joined by one of my colleagues, the esteemed Elixir wizard, Eric Ostrich. Say hi, Eric.
Hello.
Our first series on the podcast covers Phoenix and Elixir in production, and today we have a very special guest, Mr. Frank Hunleth from Smart Rent. How are you doing, Frank?
I'm doing great.
Great. Frank, to get started here, this is an unusual episode for us because of your background, so I would love it if you could introduce yourself and give us a little bit of background about Smart Rent and how you got started with Phoenix and Elixir.
Okay, so my name is Frank Hunleth. I'm one of the creators of the Nerves project. So the Nerves project is a project that makes it easy to develop Elixir applications on embedded systems. And I work for a company called Smart Rent. Smart Rent they outfit apartment complexes and rental communities with smart home style systems like smart locks, smart thermostats, and other things. And then they also provide a management system to the property owners. My work with them is they're building embedded devices to install in those homes, and Nerves is going to be running on one of them.
Which is precisely what makes this an unusual episode for us. Most of our episodes are about like web application development, but today we're really going to talk about embedded, which is very unusual. So I'm a little bit out of my depth, but Eric knows a little bit more, and Eric's going to start us off with some of our regular questions. Eric, do you want to take it away?
Yeah. So do you want to give us a quick overview of the Elixir projects that you have in production, or even just since you're part of the Nerves core team, just like any that you like are aware of?
Okay, so there are actually a few. I mean, Nerves is implanted in a variety of embedded systems. So I think when you come to Nerves, you're wondering that, like, what type of embedded system. So there are these ones with really small microcontrollers, like if you're familiar with the Arduino, those might be in those. That's not Nerves, and Nerves is more in ones that can run. They typically run embedded Linux. They do some networking, and they also usually run enough business logic where it starts to become interesting to put some Elixir code on them so they can run offline a little bit or do a little bit more localized processing. So of those projects, the initial one was one by a company called Rose Point, and Rose Point got the Nerves project on the ground, was the first success story. What they did is they made a device that they put into tugboats and towboats and some medium-sized yachts. And it was based off of a BeagleBone, which is fairly easy to buy embedded board, but they put some interfaces on it so they could connect it up to other sensors on the boat. And then they had software running that would aggregate the sensor data and communicate to the captain running it. That piece of software was pretty successful for them, or that device was pretty successful for them. And one of the things that they came back to about Elixir and Erlang was just how stable it was. It made it easy for them to code up some of their software. They were coming from their developers were coming more from a Ruby and a little bit higher level background than low level C. Made it easy for them to write, and the devices just kept on working, which thrilled them to no end. So that was the beginning. For Smart Rent, we're using the smart homes that we're deploying. There's Latote is another company that uses it to automate their warehouses. It's being used on a couple farms operations to automate the equipment there. And let's see, there are a few other uses in industry, some not announced yet, but it's also found a home for many hobbyists and many people just getting involved with electronics for the first time. So if you go to the Nerves forums and that, you can see a lot of those little projects get put up that people are making in Elixir and doing some pretty neat things with.
Cool. So our next question is, like, what made you pick Elixir? I guess going right back a bit to the start of Nerves.
So yeah. So if I rewind, I totally didn't pick Elixir. So I originated in Erlang. So the story is that my career, I started out making voice over IP switches, big ones for central offices. Built one. The company was successful. Left to go to college, and then started reading papers about Erlang and found out how I did everything in not the greatest way, and their solutions were quite good. So I was very impressed with Erlang, and I decided that I was going to take it upon myself to get Erlang in a project, and that was 2002. So it took me like forever to actually figure out a way to get Erlang in the project, and gave up in about, I don't know, 2010 or 2012 or around then. And it's just like, fine, I'm just writing something. I'm just going to see how I can do it. And the toy project I built eventually grew into the Nerves project, and then Justin joined in and made it way more awesome for any Elixir developer, and me too.
Yeah.
So totally sold me on Elixir. I love it.
So this is interesting because I think you're the first person that we've spoken to that comes to Elixir from somewhere other than Ruby on Rails.
Yeah, C and C++ all the way from me, but yeah, via Erlang. So.
And now I'm curious if there's like a whole cohort of developers out there that have come to Elixir through Erlang, or if that's actually like a minority.
Oh no, there are a bunch. The one nice thing about, I think Erlang, you get really indoctrinated to OTP pretty much head first and get it nailed into your brain. So the people that have come over, I've really enjoyed working with them just because, they really got those pieces down. Now, if you were to ask me about C and C++, I think that's a harder nut to crack to get the C and C++ developers to come over. But I would stress here that a lot of the features that are really important to embedded development mesh very well with the selling points of Elixir. It's not like this is some crazy jump here. It's in embedded, the robustness, the reliability that you need, fault tolerance stuff. Those are key things. The embedded devices are usually put places that you can't access, or need to recover at off hours, and all these things. These are really important things that Elixir and Erlang have solutions for. C and C++, we rebuild them. Now, granted, there are a few more available to us today than when I started, but I don't think there's anything quite as cohesive as the Elixir and Erlang ecosystem regarding this. Certainly, with third-party libraries, it's usually mix and match. It's been my experience with the other languages, whereas things are fit a little bit better together and follow similar paradigms.
Yeah, I was searching for this real quick. That reminds me of, speaking of C++ redoing kind of what Erlang is doing, there's Robert Verding's first rule of programming, right? So any sufficiently complicated concurrent program in another language contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Erlang.
Yeah, I feel like I've been there like a couple times. So I could definitely imagine it happening a few more times on a C and C++ project that I do. Start seeing these patterns and start replicating them.
Cool. So that kind of covered a bit of the advantages of like why you'd want to use Elixir. Is there like any disadvantages that kind of jump out?
There are certainly. Elixir's not a systems programming language. So if you want, it doesn't really you don't really want to wedge it into places where it's not right. That's why we have ports and ifs, so that we can do those system level things in maybe a page of C or maybe Rust code, and then be done with it, and then back to the Elixir land. Most of the pain points in Elixir, I think, are like shoehorning it into embedded places where it's not a good match. When you keep it at the networking, business logic, and the control logic, that's a pretty happy place, and it performs amazingly well in some other places. And I certainly know from other people in the community have done some pretty ridiculous things with managing video in Elixir on some slow embedded devices that I told them wouldn't work, and they showed me it working. So I wouldn't go with those. I think you just have to look at what you're going to do, and if it's going to be something low level, or if it doesn't quite mesh, not to try to force it and put yourself into that pain.
Yeah.
Okay, so we're going to have to add links to ports and NIFs documentation for people so that they know what we're talking about there. Moving on, Eric, do you want to jump into some of these hardware questions?
Yeah, so I guess our first question is like we've written our Nerves application. What hardware do we stick this on? Right.
So that's a good question. Nerves runs a lot of places. So we generally encourage people to start out with Raspberry Pi based boards, because our support, the open source community and the greater Nerves community has a lot of comfort in supporting those boards. And then certainly if you're trying to pull something attached a Raspberry Pi to some new piece of hardware, and no one in the community has used it, you can usually get some answers from other Raspberry Pi communities. But Nerves is much bigger than Raspberry Pi. The other official boards are the BeagleBone series of boards, which are similar take. They kind of look similar at a very high level to the Raspberry Pis. When you go through their feature list, it's much more interesting to maybe an industrial user. They have some lower level interfaces, some features that support real time, a little bit better support in some areas to keep your devices running and failing back if you happen to give it a bad piece of firmware. That one we support, and we also support x86. There's a whole bunch of people who use embedded x86 boards, which just look like, they just look like PC motherboards, except a little bit smaller and screwed into some weird container. So that's the official list. Then getting past the official list, people are making custom boards, and like for SmartRent, we made a custom board. We're basing it off of a chip module built by Octavo, which has many similarities to the BeagleBone, but it's one module that we can put on a special board that has the other components that we need. There are other groups putting their stuff on to Raspberry Pi compute modules, which is more like an embedded way of using the Raspberry Pi. I'd say it's mostly supported by Nerves, but I don't think that we have a regular maintainer, but still it's slightly different than just taking a Raspberry Pi. There's NXP has a set of processors called IMX6, and there's other varieties that people can run Nerves. When it comes down to it, porting Nerves to a new platform is not the biggest deal if you're familiar with tool or have used a tool called Buildroot and have some passing familiar to embedded Linux. There are a couple configuration options. You can kind of copy paste them from stuff that the board manufacturer will give you. We provide a route to doing that. Certainly if you're building a lot of boards, or if you're planning on shipping a lot of units, looking into custom hardware or building your own board starts becoming a more interesting option to lower the cost.
Cool. So now that we've picked out our hardware, how do we get our code to this hardware?
So there are a couple of ways. We start everyone off using SSH. You can SSH to the device by default and you get an IEX prompt. Right? You don't get a shell prompt. You get the IEX prompt because it's Elixir running, and you can do stuff there. But you can also, we have a little script that's lets you upload firmware files. So Nerves compiles down to a release, and then there's a post-processing step which zips up the release and puts some metadata and optionally cryptographically signs it. That we call a firmware bundle. That firmware bundle file is effectively just copied over to the board but through SSH and updated. So that's the development, and that mode works for small numbers of boards. Some people deploy that with like Ansible. Then the other way that we're working on a lot on now is a service called Nerves Hub. It's a server and a client. So Nerves Hub is the server which you'd upload your firmware file to, and then the device is also connected to the server. And through configuring what we call deployments on the server, you can say a device connects with an old version of firmware, send it down this new version of firmware, and it will automatically update. And there's a laundry list of features on how you can roll out updates, but you're using a centralized server. We operate nerveshub.org, but you can set up your own server instance. And then the third way is just do your own thing. There are a lot of people that make ad hoc firmware update servers that just ping a web server for the latest firmware image or some variation on that theme.
All right. So now that we've got our code deployed to the application, it's out in the wild. How do we secure this thing?
Right. There are many aspects to this. A lot of what I have to say is specific to the SmartRent scenario or a couple others I know. So you always have to keep that in mind. But out of the box, we're forcing everyone to use SSH in there. So the unfortunate part is that only lasts so long because it's a secret key option. The Nerves for security reasons, it's not great to pass around the secret keys for logging in or updating firmware onto your box unless your environment is behind a firewall, like some industrial factory kind of setup. When you move into the Nerves Hub realm where you have devices that might be behind firewalls or just anywhere in the world, then things start to get, you want to start to do a little bit more and turn off SSH and secure the connection to the Nerves Hub server and also secure your firmware chain. So for our Nerves Hub, we require firmware to be signed. So when you build your firmware image, and you want to ship it to production. You have to cryptographically sign it using private key. That's where the public key is put on the device, so that no matter how that firmware file gets to the device can always check that says, yes, it came from a trusted location. So then, you peel back the onion a little bit, and like, how do you authenticate to the server, to the Nerves Hub server? That we use HTTPS, just like pretty much everyone else. I think the device authenticates the server just like you would in any other typical web interaction. But we also have use client-side certificates to secure the devices. And this isn't something that's specific to us. It's the various MQTT, the brokers, the IoT brokers that people use do a similar thing. So for those, every device gets deployed with its own certificate. And the way we manage this with Nerves Hub is that you can either create your own key locally. We don't recommend that approach, but it doesn't require any extra hardware because it's a very manual process, and then you have to protect and rotate the keys. The approach that we're using at SmartRent and the approach that they're using, that they're starting to use other places to put a chip on their main board. We're using one from Microchip that it stores the private key part inside the chip. There's no way to get it out. What we did to make it a little bit easier for hobbyists and others is we made a little board called the Nerves Key board, which has this particular chip on it, and it works with the open source client, Nerves Hub client, so that you can create your own, so that your devices can each have their own certificate with a protected private key. And it just fits into the Erlang's SSL stack to authenticate with the server. Roughly speaking, that's part. And then I'm trying to think of how far to go with this. It's like my experience
in a nutshell.
It's like peeling back the onion. Like once you keep on, the problem with a lot of these devices is that people have physical access, by design, they have it. So there are additional, if you're storing something critical on the device itself, you have to take extra precautions to secure that. And I think what a lot of people have done is moved a lot of that sensitive data over to the server, so the device is compromised, that they have to go a little bit farther. But certainly this is a big topic.
Yeah. Is there a Nerves security page somewhere that people could start looking into?
So the Nerves Hub documentation talks about the end-to-end and the client server security. If you want to get into more details, the crypto chip, we've documented a lot of that at the Nerves Key GitHub. So there's actually two repositories, one for the chip and one for our configuration of it. The chip is highly configurable, and we labeled our configuration Nerves Key. It's certainly a good starting point for everyone. And then depending on your application, you can use the cryptographic chip for more stuff if that makes sense.
Cool. All right. So we'll make sure to include the links in the description for that. So let's keep moving on. So we've asked other people of like how they cluster, but I imagine that's pretty different for embedded stuff. So is there anything that's kind of similar to clustering?
Yeah. So when you say clustering, I immediately think of the Erlang distribution. Yeah. And I do not know of production use for Nerves devices with Erlang distribution. I could believe that they exist, but the projects that I know are more like toy-like projects because it's just kind of fun. I guess where I take this is that the typical protocols that we run to our MQTT. So these devices call home to a server, and the favorite protocols are the ones that you'd expect. Either someone has a RESTful interface, but it's more often that they have an MQTT interface. And there's a Elixir library called Tortoise, which I think seems to be, almost everyone seems to be using it nowadays. There used to be a couple others that got used, but people have been switching to that one. It's lets you connect to AWS, IoT, the other big brokers. Pretty simple to integrate in. And then since this is a Elixir podcast, I have to mention that people are also using Phoenix channels to connect up, because the companies that are using Elixir or using Nerves usually have a team of server-side developers, back-end developers who are strong in Elixir. I think that's like the default. And channels seem to be very low barrier to get started. So
yeah, I think I saw at ElixirConf this year for the Nerves Hub announcement. Is Nerves Hub channels?
Yes.
Cool.
Nerves Hub is using Phoenix channels. So,
Cool.
yes.
So then, there's a good example to go peek around.
Yeah. So no, Nerves Hub is full speed forward on Elixir-based technologies, and where they fall short, the answer is to fix them. They meet our
Cool.
needs.
All right. So I guess our last like hardware related question specifically is like, how does Elixir compare to C or C++ or any kind of other embedded development?
Well, it's different, right? I think that that there are a couple fun areas on Elixir compared to the C and C++ development. One of the fun areas is when you make a mistake in your code and you just copy paste something into the IEX prompt. I mean, it's just like this is like boring stuff, and there are way better ways of doing this. But if I were the C developer who had to recompile and then stop and start their app, I mean, that's pretty cool stuff. So
better developer experience.
I think that I'd like to say that in many ways that there's a better developer experience. I also think that there are many ways that we can improve. So I don't want to feel like I'd ever give the impression that there's an endpoint here. But that certainly is a fun thing. Anything that has to do with binary pattern matching is like crazy fun for me, because it's like I go from these libraries, and I guess one thing to back up is to maybe talk very nicely about hardware people and electrical engineers, and say something about how they like to cram every piece of information in various numbers of bits. That if it takes 3 bits, it takes 3 bits, and that leaves 5 more to put some other random thing that's totally unrelated to that one flag in that field. And binary pattern matching has just a way of making the code to interact with this stuff so pretty. I guess from that point of view, I've almost gotten to the point where Bitwise is a code smell. The Elixir Bitwise library. If I ever see that, I'm like, oh no, something was just copy pasted. So if I think about this a little bit harder, I can delete like half the code with appropriate patterns.
Yeah, I've done a bit of, for better or worse, telnet parsing, and there's some out of band stuff that you can catch that like doing pattern matching was like so much nicer than I don't even know what I would have done. But
no, it's just totally a brilliant feature. And it's one of these things that I would imagine that your audience, if you've gone through the pain of dealing with all the bit manipulations, you'll be like, oh, this is like the best thing since sliced bread. And if you haven't, you're like, why are we even talking about this?
Cool. So I guess maybe speak a bit more about Nerves itself and like kind of what's in there, or if there's any competitors to Nerves.
Oh, right. So let me just give the quick summary. So Nerves is a set of tooling, really. When it comes down to tooling and cooler libraries, that's where we try to focus the Nerves project now. The Nerves ecosystem has a lot of other things surrounding it. So that's part of the nice part about it, keeping the core small, is we can focus on that and then pull in things from the community, either be it ports or hardware associated libraries and whatnot. There are other ways of programming in Elixir on embedded systems that I'm actually quite excited about too, even though they aren't Nerves. And so I guess I'd be remiss to say if you had a Raspberry Pi with Raspbian, you can program Elixir on that, no problem. It's like a PC, you program Elixir on it, you're good to go. A lot of the Nerves libraries will just work out of the box. And that's on purpose. A lot of us prototype stuff there on Raspbian when we have no clue what we're doing. But we also like to keep things working there because we know that's a particularly low barrier to entry to people who are coming from the Raspberry Pi. Another project that is the GRISP project, and that one started out as a embedded Erlang project. So it has slightly different roots. If you take a very distant step back, it has a lot of similarities to Nerves. Some of the things that the GRISP group prioritizes that are interesting are, one, they don't build off Linux. So Nerves we use the Linux kernel as our way of getting access to device drivers for all the kinds of hardware and ports. So GRISP takes a different approach. They use a real-time operating system, so it's a little bit thinner. They also have been running on microcontroller boards. So the GRISP, if you want to program using GRISP, their infrastructure. You have to buy a board that runs that they've ported the Grisp libraries to. The exciting part about Grisp coming up is that they're working on a new board, and it's using an NXP IMX6, which is a processor that can run Linux. And since it can run Linux, it can run Nerves. And since the people who work on the Nerves project and the people who work on the Grisp project talk to each other, we'll have Nerves running on that board. So that board is probably going to be a pretty interesting board to quite a few industrial users who have various needs that aren't met by the Raspberry Pis and would actually take some work to get a custom board like a BeagleBone up to speed. Plus, the IMX6 has some cool features that the BeagleBone doesn't have. So, in any case, this is a very exciting project for both of our teams, and hopefully there will be some announcements soon. Maybe, I don't know when this podcast is coming out, but it could be sooner now. So, about that.
Well, I'm looking forward to that, and I think that we're running pretty short on time here. So, Eric, maybe you want to take us through our wrap-up questions?
Yeah, I think we just have the one. So if you could give one tip to developers out there who are or maybe soon running Elixir/Nerves in production, what would it be?
Oh, there's so many things. Combining down to one. I should have really prepped better for this one. But I think the key to being successful with Nerves is just keep the system simple. I mean, it's like I think that's the whole beauty of Elixir. I know this is totally generic, and this is probably the lamest answer ever. Keeping these embedded devices simple is what makes them robust and last long and easy to deploy. I mean, we live in a network world, so you don't need to cram the whole world onto the embedded device. I think there's a lot of success to be had. Certainly the devices out there have found nice splits between what goes on the embedded device and what goes in the cloud to keep the embedded device as reliable as possible. And I think that's led to success and happiness from the people who have to maintain these devices.
Very cool. Well, Frank, thank you so much for being on the show.
No, thank you. It's great talking to both of you.
It's really a pleasure and an honor. You're a luminary in the community, and I mean that really. And before we let you go, are there any plugs you'd like to make before you head out? Obviously, Nerves, but also like if people can find you somewhere, or like why should they try to find you and reach out?
Oh yeah, of course. People should always try to find me and reach out. I'm human, so I can only get back to as much as humanly possible. But please reach out on the Elixir forum. Elixir forums right now underutilized for Nerves people. We love our Slack channel. We're present on both. Shout out to Justin Schneck, Connor Rigby. He's always on. Greg Meffert. These are all Nerves core team people. And there's certainly quite a few other people who aren't core team that are super helpful to me and others. So that's where you reach them, is on the Elixir forum, and tag your post with Nerves and on the Elixir Lang Slack on the Nerves channel.
Awesome. Frank Hunleth, everybody. Once again, this has been an episode of Smart Software with Smart Logic, talking about Elixir in production. Join us next time for more conversation with folks running Elixir in production. And if you are interested in learning about Elixir, this is the podcast to learn. Eric, Frank, thank you so much for your time, both of you, and we'll see you all next time.